Good day. I'm Romelyn Baptista, and I'm going to discuss the fluorescence spectroscopy. For the physical principle, we all know that the electrons have a specific spin associated with them. You can see that they have either spin up, where spin points in the same direction as motion, or spin down, where spin points in the opposite direction as motion. These electrons pair themselves with electrons having opposite spin to theirs. As a result, the net spin of the pair is zero. Furthermore, since they have opposite spins, they are said to be in a singlet state. So the physics behind fluorescence involves the different electronic states and vibrational states, which is shown in this Jablonski diagram. Looking at the energy level diagram, we can try to understand how fluorescence is produced. In the ground state of molecules, the molecular energy are constant and in minimum value. When the fluorophore is exposed on an external radiation, it absorbs its energy. And due to this absorption, an electronic transition takes place and molecules transport to higher electronic states, or what we call as the excitation. Lambda 1 refers to the wavelength of light absorbed by the molecules during the excitation. The fluorophore remains in this state for a certain time, around 10 nanoseconds, and after that, the fluorophore will return back to the ground state. In this transition, energy is released in the form of emissions, and this phenomenon is called fluorescence. This transition involves less energy than the original absorption, so emitted wavelength is greater than the absorption wavelength. That means lambda 2 is greater than lambda 1. Take note that each fluorophore has its own characteristic properties, which means each of them will yield a unique fluorescence spectrum. A fluorescence spectrum is a plot of the fluorescence intensity as a function of wavelength, which will be shown later on in the application. Moving on to the principle of fluorescence measurement. Again, we can refer to the diagram shown here. As shown, the detector is placed perpendicular to the light path of emitted source, and the analyte is placed in the cuvette. These instruments are employed with multiple filters or monochromators. One filter is placed between the light source and the analyte. This filters helps to achieve a good monochromatic beam of a particular wavelength that will be absorbed by the analyte. Typically, the primary filter permits short wavelengths needed for excitation. The secondary filter permits is placed between the analyte and the detector. This filters out the phosphorescence radiation of the stray light and only fluorescence is measured, and the secondary filter permits long wavelengths associated with the emission. Now, I will discuss the applications. Fluorescence spectroscopy is a rapid, sensitive method for characterizing molecular environments and events. For this reason, fluorometry is widely used in the field of research compared to other analytical techniques. So the first study is entitled Fluorescence Spectroscopic Analysis of the Interaction of Papain and Bromelain with L-ascorbic acid, alpha-tocopherol, beta-carotene, and astaxanthin. This appears in International Journal of Biological Macromolecules with an impact factor of 6.78. So for the background of the study, papain and bromelain are cysteine proteases that have important roles in many biological functions. So binding of these enzymes with bioactive molecules have been studied due to their remarkable application prospect in the field of medicine. On the other hand, L-ascorbic acid, alpha-tocopherol, beta-carotene, and astaxanthin are four classic dietary antioxidants. And knowledge of the interaction between these antioxidants and proteases is desirable since it was found out that their interaction causes conformational changes of the proteases which reduce its biological activity. So for that reason, fluorescence spectroscopy will be used to acquire fluorescence measurements that will help give accurate data regarding the binding mechanisms of the four antioxidants to papain and bromelain. So experimental results suggest that these four antioxidants can bind to papain and bromelain and quench the fluorescence of them. As shown in the figure, The fluorescence intensity of the proteases decreases regularly with increasing antioxidant concentration. This result suggests that the fluorescence quenching of these proteases by antioxidants is mainly concentration dependent. It was also found out, based on these results, that binding of four antioxidants may induce microenvironmental changes of the proteases by conducting synchronous fluorescence spectroscopy. And lastly, quenching mechanisms of these proteases by the four antioxidants are all static at lower concentrations of antioxidants. So the next study is entitled as follows: Monitoring the binding of serotonin to silver nanoparticles, a fluorescence spectroscopic investigation. This appears in Journal of Photochemistry and Photobiology. So with an impact factor of 11.72. So for the background of the study, serotonin is an important monoamine neurotransmitter that plays a vital role in the regulation of various cognitive and behavioral functions. So interaction studies between serotonin and nanoparticles are highly essential to develop because this is needed to understand the effect of nanoparticles on monoamine neurotransmitters. Also, binding of metallic nanoparticles with serotonin has important implications for safe clinical application of nanoparticles, such as in drug delivery. For that reason, a steady state and time domain fluorescence measurements were carried out to monitor the interaction and binding parameters between serotonin and silver nanoparticles. So to define these terms, the steady state measurements, in steady state measurements, a sample is illuminated with a continuous beam of light and the fluorescence emission spectrum is recorded. Whereas in time resolved measurements, a sample is illuminated by a short pulse of light after which the intensity decay is measured. So that's the difference. So results suggest that formation of a non-fluorescent complex in the ground state, indicating that there is static quenching along with a radiative energy transfer among them. And the static quenching observed also indicates that the interaction has a hydrophobic nature. So another information obtained from the result is that binding of serotonin and silver nanoparticles increases with increasing temperature, and this is due to the rise in the mobility of the molecules, and therefore it increases the sensitivity and association of serotonin with silver nanoparticles. As mentioned, these interaction studies will have enormous application in drug delivery. The last study is entitled as follows. This appears in Journal of Luminescence with an impact factor of 3.58. So for the background of the study, norfloxacin has a wide application in human and veterinary medicine because of its antimicrobial activity and excellent pharmacokinetic features. However, NFX promotes antibiotics pollution as it is difficult to degrade in aqueous solution and its residues have been detected in sewage and other environment. Hence, it can potentially threaten the people's health. Since NFX is a fluoroquinolone antibiotics, in this paper, the synchronous fluorescence spectroscopy was carried out to set up a method for determining NFX content based on bovine serum albumin as a fluorescence probe. As can be seen from figure 4, the synchronous fluorescence intensity of BSA gradually decreased with the increasing concentration of NFX, which indicate that the interaction occurred between NFX and BSA. Furthermore, figure 5 shows the fitting curve between the concentration of NFX and the fluorescence intensity of NFX and BSA interaction by least square method. It can be seen that as concentration of NFX increases, the fluorescence intensity also increases. These results show that there is a good linear relationship between the fluorescence intensity of NFX-BSA interaction and the different concentration of NFX. So that is all for my discussion. Thank you.